All right, one final short video. The purpose of this module was to learn a lot of skills, Skynet, Afterglow, but also to come up with the colors of the planets best we could. So let's run through the planets really quickly and talk about what gives them their colors. And then you can compare the colors in your images to the colors that we're going to be looking at here. Okay, so Venus. Venus is not observable most of the time. Most of the time it's too close to the sun. But if you were lucky, you might have gotten Venus images. And its cloud top, sometimes we refer to it as the surface, but it's really the cloud top of the planet, is pretty nondescript. White and some yellow white. These are not clouds like on Earth. These are not water ice clouds like we have here, but sulfuric acid clouds. And they give it its color of white and yellow white, and it blankets the whole planet. There are no gaps in this cloud cover. Now, Mars is easier to observe. Most of the time, it's too far away. We can observe it, but we don't see any detail because it's far away. And you'll just get a blur. And if you're using percentile color balance, that blur will be white because that's what percentile color balance does. There are no background stars in these images. Mars is so bright. We have to expose so briefly. We don't get background stars, so we can't photometrically color balance. So for this one, you may have had to manually color balance. But the color of Mars is, of course, red. And this is due to iron oxides in the soil. Now, the one difference you can have is the polar caps, or if there's cloud cover. But again, this is not water ice, polar caps and cloud cover. It's colder there. It's carbon dioxide ice. Now, there is some water ice mixed in, but it's primarily carbon dioxide ice. And sometimes you see it just the cap, and sometimes you see cloud cover. On rare occasions, you may get a planet-wide dust storm, which will blur all the features. Let's tackle Jupiter and Saturn together. Their cloud tops have 3 layers, same 3 layers for both. At the very topmost layer, you have ammonia ice, which is butterscotch in color. Beneath that, you have ammonium hydrosulfide ice, which can be different shades of brown depending upon the temperature. The deeper you go into the planets, the warmer it is, and that changes the color of this. And below that, you have water ice, which is white. So the difference is the surface gravity. Again, it's not the surface, it's the cloud tops, but it's called surface gravity. And it's just much greater on Jupiter. It's like 2.5 times stronger on Jupiter. So it squeezes these 3 cloud layers really thin. And sometimes it creates little holes, and you can see through one to the next, and you get all this color variation depending upon what layer you're looking at. Here's a to scale model here. This is Saturn, and here's 0 corresponding to the cloud tops. And here's the ammonia ice, butterscotch, ammonium hydrosulfide ice, and then water ice. And Jupiter, if you compact its image to the same scale, 0, 0, minus 100, minus 100, everything's more stretched, or squished. And you see the ammonia ice, the ammonium hydrosulfide ice, and the water ice. And below that, you have kind of the normal composition, hydrogen, helium, and carbon, nitrogen, oxygen down there in the form of methane, ammonia, and water. That's all mixed together down below. But the cloud tops, ammonia ice, ammonium hydrosulfide ice, water ice. And again, on Jupiter, it's squished so thin, you get breaks in the clouds and you can see down to lower layers that are different colors. On Saturn, its surface gravity is about the same as Uranus's and Neptune's and Earth's, about 1 gravity. If we were floating there, on some kind of floating platform, would weigh the same on Saturn, would weigh 2.5 times as much on Jupiter. Anyway, because of the lower gravity, they're not squished as much. They're thicker and poofy, and you just don't see through the top layer. And so you're just looking primarily at ammonia ice. That ammonia ice is butterscotch in color, and that's what gives Saturn its color. Now, the rings are primarily water ice, and so they should look a little bit whiter. Then you have the moons. These 4 in the back are the moons of Jupiter, the 4 large moons of Jupiter: Io, Europa, Ganymede, Callisto. Europa, Ganymede, and Callisto are covered in ice, so they should be white or shades of gray. Europa has this large ocean under the surface, and due to tidal strains, the surface is always cracking and water is leaking out on the surface, refreshing it, keeping it nice and white. These others are farther from the planet. They're not being tidally distressed as much. And so the surfaces are pretty steady, and they've been getting darker with time as micrometeorites land on them. But still different shades of white or gray. Io will be different, and you should be able to see this in your image. Compare the moons. One of them, Io, should appear yellow. And that's because it's a volcanic moon, lots of sulfur and stuff, and it's coloring it yellow. If you image Saturn, it has 1 large moon, and that's Titan, and it's large and it's far enough from the sun that it's cold enough it actually retains its own atmosphere, primarily nitrogen, but there's haze in there that colors it orange, and it should look orange in your image. Where the other moons around Saturn, they're smaller, fainter, but they're kind of shades of gray. And although not pictured here, Uranus doesn't have large moons, medium-sized moons, and they should all look darker than the planet. We'll talk about the planet in a second, but Uranus and Neptune are kind of blue or blue-green. These should look darker or redder than those colors. Going around Neptune, you have Triton. It's also a large moon, a little bit smaller than Europa, but bigger than these, and it's also dark in color compared to the planet of Neptune. So look for colors in your moons as well. And finally, here we have the planets Uranus and Neptune. They are blue or blue-green in color. This is because methane clouds. They have clouds of primarily methane ice. It absorbs red light, reflects, scatters around blue light. Also, there's just the natural scattering around of short wavelength light. Like in our atmosphere, short wavelength blue light scatters more easily, making the atmosphere blue. Same deal here. Some of the blue that we're seeing is due to methane absorbing the red, but some of it's just due to the blue sunlight being scattered around preferentially. So they're about the same color. Uranus is a little hazier, a little less blue, probably due to haze in its upper atmosphere. The weather on Uranus is a little bit more sluggish than on Neptune. Okay, that's it for this video. Hopefully that information will help you to interpret the colors that you see in your images.